Hello everyone, my name is Konan Allaly. Welcome to our session on image analysis. In this video, we will talk about big data handling. The lecture aims to understand data, big data, and data handling. At the end of the video, we'll provide some good practices for handling big data. Data is a raw material from which we can get information and knowledge. In other words, data is information, especially facts or number used as a basis for reasoning, discussion, or calculation. In computing, data is information in electronic form that can be stored and used by a computer. A deeper understanding of data involves understanding a wide range of concepts, including data types, data analysis, and data usage. In this video, we'll focus on data types, research data, and file formats. Data types are used to classify variables according to their similarity. We have four types of data. First, nominal data, which are used to classify variables without any order. For example, names of people or hair color. We also have ordinal data, which are used to classify variables with a specific order. For example, expertise, beginner, intermediate, or expert. Another data type is discrete data, which are expressed in numerical value. For example, number of students. The last data type is continuous data, which are expressed in fractional value. For example, weight of person or freezer temperature. Data is crucial in research because it is used to validate original findings. We have four types of data in research. First, observational data, which are collected by observing and recording events or behavior. In medical field, for example, we have CT or MRI image data. We also have experimental data, which are produced by a measurement and are often reproducible. For example, in genomic field, we have DNA sequencing. Another data type is simulation data, which are generated by test model and are often used to model complex systems and processes. For example, we have climate and weather models. The last data type is derived data, which are produced by processing. For example, result of segmentation. Now, let's talk about file formats. Depending on the needs and the usage, data will be stored using specific file formats. For example, we will use the extension .txt for text file. We will use .png or .jpeg for image data. We will use MP3 for audio and .avi or MP4 for videos. What is big data? Big data is an extremely large volume of data and data sets in diverse forms. Big data can be collected from various sources like social media or medical records. We have several possible usages of big data. Let's give some few examples. Big data are used to develop new products. For example, companies like Netflix use big data to anticipate customers' demand. Big data are used to drive innovation. For example, some companies examine trends to implement the dynamic pricing. Big data are also used in research when they enable training machine learning models instead of programming them. Big data are also used in healthcare because they help to improve diagnosis and treatment following up. As we saw before, data and big data are very important for various applications and companies. Dealing with big data involves many challenges. Let's talk about few of them. The first challenge is data storage. Data sizes are doubling almost every 2 years. The traditional storage capacities are quickly outdated. Companies need to use some new solutions, such as cloud storage. Another challenge is data varieties. Data are collected from various sources and are in different formats. It is a challenging task to aggregate and process them efficiently. Data quality. Some missing information can make the processing very complex or impossible. The last challenge we would like to talk about is the security and the privacy. Security is crucial for institutions which are dealing with medical data because any data leaking can create several damage, such as patient deaths. The last part of this video is about data handling. Data handling refers to the process of managing, storing, manipulating, and accessing data in various formats. It includes a wide range of activities from collecting raw data to processing and analyzing it for meaningful insights. Now, let's talk about some good practices for data handling. First, establish clear data handling policies. We need to develop efficient data handling policies outlining procedures for data collection, storage, processing, and sharing. In research, for example, we need to build a strong file naming approach, including the experiment name, the date, and the purpose. Second, ensure the data quality. We need to ensure the data quality by verification, cleaning, and visualization to make the processing easier and get meaningful information. Third, use relevant data sources. We should select data sources that are relevant to our objectives and align with the questions we would like to answer. Fourth, optimize data representation. We need to choose appropriate methods for representing our data, including graphical representation and statistical summaries. Fifth, secure sensitive data. We should implement robust security rules, protect sensitive data from unauthorized access or manipulation. We should encrypt data during transmission and storage and regularly edit data access and usage. Final, the documentation. In the research field, it is important to provide accurate documentation for the tests done and the related files, such as the source codes, the input files, and the output files. In this lecture, we have learned more about data, data types, file formats, big data, and data usage. Data is important in research because it helps to validate new findings. For companies, it helps in decision making and drives innovations. Optimal data handling ensures companies save time and money.